Hello, in this video I am going to be working on my project which compiles Rust into .NET assemblies, Rust, C, Cogent, CLRL. It's basically a Rust compiler module which takes in the Rust intermediate representation mir and turns it into the .NET intermediate representation seal. And yeah, currently I am having some trouble getting Rust string formatting to work because, well, Rust string formatting is a fairly complex process. There is a lot of moving parts there, and something along the way it doesn't work properly. Like, there is some small miscompilation which causes everything to crash. It basically causes a buffer overrun. Instead of copying part of the format string, it like goes past its end and it tries to write to some unrelated memory. So this is something I would like to fix, but I have some issues debugging it because currently there is really no way to see the fields of a Rust type from .NET. Normally in .NET you would use the ToString method to turn a type into its like displayable representation. It's kind of similar to the display or debug type in Rust, but there are some subtle differences. So today I would like to start working on implementing this function for all Rust types that I meet, because well, it would make debugging far easier. So okay, so first of all I will need to modify the type definition because this is the definition of a type, and it basically stores information about things like its accessibility, its name, if it has types inside it, because .NET types may have other types inside of them. You may have a type A, and inside of this type you have a nested type B, and it also can have some functions. I already have support for adding virtual methods. Virtual methods, well, ToString is virtual because you can override it with your own implementation. The default implementation for object just returns an empty string, and I would like to return a formatted string. So first of all, I would like to create a function that will create, well, a function that creates this .NET function. It will basically take in an ADT definition, because ADT def, this is an internal Rust C type which represents either a struct, enum, or an union. And by using ADT, well, I need to handle all of those cases, but I will probably just start with support for struct types. Yeah, so here I will take a definition, ADT def, a reference to the definition of the type, and I will return a method, appropriate method, the ToString method. Okay, so now, yeah, I don't know, I would like this video to be kind of something like, it's not a devlog, it's more of a live development session recorded, something along those lines. I tend to watch those videos and from other people, and I wanted to do something like that myself because I thought like this project is quite interesting, and I don't know, maybe someone would like to watch it, would like to understand how it works exactly behind the scenes. So in this video I will also try to explain why certain things work the way they work. Okay, so we'll create a new method. Okay, what? Okay, we need to import methods, and now we need first of all its access modifier. We will make it public because ToString is public in .NET generally. You can call it from any other type. It's a virtual method. Well, its signature, it takes in nothing as input and returns a string. In .NET, generally instance methods have a hidden implicit this argument. So for example, when I have this function public void m, because it's not static, it takes in a hidden argument of type of the type of the class this method is defined in. So if I, for example, had an integer here and I don't know, I printed it. Oh, that's right line. What's happening? That's kind of weird. Okay, so this website was very helpful during development because it shows you into what seal operations your a bit of C# code is done. So here I can see, for example, that this method called m, you can see here that it loads argument number 1, not number 0. If I made the same method but static, you would see that it will load argument number 1 because as a general rule of thumb, if a method is an instance method, then its first argument is this is hidden, like it's a hidden argument of type this. But in my project, I make those hidden arguments still present in the function signature type because I don't want to deal with the differences between instance and static methods up to the point when I emit the final seal. Then I just remove this implicit this argument, but because I preserve it during the codegen phase, all the optimizations can work the same. There doesn't need to be any special handling for optimizations. There doesn't need to be any special handling for checking because I have additional validation layers that check if a method is valid. So normally I would have to, I don't know, check if it's static or not. But if I just preserve this argument and strip it only at the very last moment, only when I am saving the seal, then I can simplify a lot of my work. So that's why here this will need to also know the type of this type definition. So we'll it will be this is the internal Rust compiler representation of a type. I'm taking here, and I am also going to take in a type cache as an argument. This is my internal. It's my internal. It's a data structure which basically holds the information about which types I processed already and what are the results of this processing. It basically stores information about, I don't know, if I have already processed the vector type, I don't need to process it anymore. So it basically stores the results of things like type conversions between Rust and .NET, because the type conversions are relatively expensive, so I would like to cache those results. And it also simplifies some stuff because since I have normally there's some weirdness regarding self-referential types. If you had a type that references itself, then it's quite hard to figure out if you have already processed it or not. But by storing all of that information in the type cache, I can basically avoid cycles. I can easily resolve them, and I can speed up my project significantly because otherwise I would have to process some things many times over when I have already done it once. So I'm going to right now use the type cache to get the as a general convention, I try to have the internal Rust type representation, like variables refer to it, be ty, and my representation I usually call the variables that store it tpe, basically just to make distinguishing between them easier. So and I know that I need the type of this of the type I'm creating the ToString method for. So I'm going to call type a special method on type cache. It's called type from cache. It either processes the type or just retry or just gets it from the cache. Yeah. So we also need a type context because the Rust compiler passes each code gen. You need a type context. It's basically a giant type which stores the information about. Well, it's a giant structure that stores information about all the types. So it stores type definitions. It also stores all functions. It's basically a big bag for a crate to be stored in. It's basically a big bag that contains all the information necessary to code gen a crate. So we need to get it and pass it to the cache because it uses it to call some Rust compiler functions to look up some data about those types, like what kind of fields do they have, are they sized or unsized, and things like that. This argument we can set to none for right now. Here I basically pass the Rust function that I'm currently processing to type cache, because then it can substitute types, like it can turn a generic type into a concrete one based on where is it used. So in order to perform substitution, it needs to know which instance of a generic method you are using. So that's why it needs to be passed. Right now I probably should method. It even suggests, yeah, and also lifetimes, because all of those types have lifetimes besides type cache, which doesn't have a lifetime because it's this type, like I have created it and it doesn't reference any internal compiler structures, so I can be sure I could even serialize it and reuse it across different code units, but I don't do that because it would be kinda the performance benefits would be negligible, and there's some small potential for issues there, so I basically don't do that yet. Okay. So here, this will basically retrieve this type from the cache, and yeah, so now we can create the signature of this function. So it takes in one argument of type this, so it takes in the this type, and it returns a value, a .NET type string. So it returns the string type. .NET type ref is a more general, more like specialized version of type, of my internal type representation, because this represents like a class or a structure from .NET, and my more general type class can represent also like pointers and stuff like that. This just represents a reference to a .NET type, well, as the name suggests. Because I'm also returning a reference to it. Okay. Yeah, and a couple more arguments. Okay, so now I need to pass in the name of this method, which is ToString. I think we'll also need a local variable to store the string we are currently creating. Like I could not have this. This would just make stuff easier if I have a local variable to store the string I am currently operating on. It would just simplify some stuff slightly. So I'm going to create one local variable. I won't give it a name yet. And its type will be once again string. Something. Okay, and that should be it. Yeah, so now we have started creating a method, but we also need to add some seal operations to it, because right now this method is completely empty, so it will do nothing, and it's also not valid. Like the runtime will insert one return instruction if a method is empty, but like the assembler will do that, but this method also needs to return something, so we have to create a string and return a string, otherwise this will be an invalid method and it will behave in an undefined way, because it will return some garbage as a string reference, which doesn't really make sense. Okay, so now we need to create a list of operations which we will use to create this type. Okay, so first of all we need to create since we are describing some type, I would like to mimic the way Rust formatting works for ToString. I would like it to be very similar to Rust formatting, because then once again debugging will be easier. Like I'm already familiar with the Rust with the way Rust formats strings, so I would like to mimic that in my tooling, because this is once again a debug tool. I plan on supporting Rust formatting in the future, but it just doesn't work yet. I'm currently debugging it, so I need to improve my tooling. I can't yet sadly use the built-in formatter, so I have to kinda jerry-rig my own one. Okay, so first of all okay, now it should start. Why doesn't it? Oh, I didn't import this type, so that's why I have no suggestions. So we will load a string on top of this, because seal is based on I call it an imaginary stack, because .NET assemblies are generally, you can imagine them as programs for a made-up computer, which operates on a stack and has no registers, but has an infinite number of typed local variables. So and this particular operation kind of pushes stuff on top of this stack of the imaginary machine. I'm calling it an imaginary stack because it doesn't exist anymore when your code gets JIT compiled. After JIT compilation, it uses registers because it's compiled for your particular architecture, for example for x86-64 in this case. But the .NET assembly format, like kind of just like JVM operates on the Java virtual machine, operates on a virtual made-up machine. This operates also on a made-up machine, but it just gets JIT compiled into native instructions. Okay, so now we have to have some sort of, we should start formatting by, in rather general, you start the formatted version of a type starts with its name, so we will need to have the name of this type. And I should have a utility function for that. Yeah, ADT name. It basically takes an ADT definition. I forgot about that. That's kind of important. I didn't take in the generic, because ADT definition is a definition of a type. It doesn't refer to any specific type. For example, it refers to a vec T, but it doesn't refer to a vec U32 or vec U64. In order to have a more concrete type, you need to also pass the generic arguments. So I'm going to also need that. This will be a reference to list of generic arguments, each one of them with this lifetime, and also this reference will have the same lifetime, because this list, it's once again, it's an interesting compiler optimization. So there's some like deduplication. Like when I get this list, it lives as long as the codegen unit I'm compiling lives. So this like saves on a lot of memory. It makes the Rust compiler faster, but it means that each of those lists has a very, very specific lifetime that I have to once again follow. Okay, so now I have the ADT definition. I should probably rename this from dev to ADT dev, so it will be a little bit more clear what's going on here. Okay, so now I have the name of this. Oh, I have to dereference that here. Okay, this type is copyable because this ADT definition isn't really a whole definition. It's just the ID of the definition, because the definition itself is stored within the type context, and this is just a reference to definition ID, so that's why I can dereference it and copy it easily. Okay, so now we have the name, so we can use the name, and then we can like kinda do it the same way as we would do that in Rust. So in Rust, in formatting, when formatting something, generally the default formatting will start with curly brace, so something with this thingy. So I'm using 2 here to escape it, so the formatter knows that it's not a variable, that is just this particular character. In the future here we will handle all the fields, but right now I just want to check that this method gets created properly, like that it gets inserted properly, and then I will handle fields later, because once again, structs, enums, and unions, they have slightly different field rules regarding to fields, and I would like to display, for example, for an enum, the current variant and the fields of the current variant, instead of displaying just all the fields, because that will be too complicated. Okay, so fields will be done in the future, but now I want to just finish creating this simple seal method. So I will also add yet another constant string. Yeah, here I would like it to assign it to the variable, local variable number 0 with index 0. So we'll load local. No, here we will. I'm sorry. Here we will set a local variable, and here we will load it and then append to it, and then set the result. So we'll first load the local variable 1 on top of this imaginary stack. No, I'm saying 1. It's the local variable number 0 because it's local variables in .NET are 0 indexed. Okay, so first we will, and then we have to concatenate strings, and to do that we'll need to use the string concatenation. So here I can show as an example of how it works in C#. We can have ABC plus DF, and so this is true. Okay, debug, and we can it concatenated them instantly. because it still loses some optimization even in debug mode. Okay, and now we should see, yeah, call to string concat. So we'll have to also call string concat. So we'll have to, after loading this character, we'll have to. So now we have the beginning of the formatted type string, and we have its end, and we have to basically connect them together. So we have to call the concat method. In order to do that, we'll have to create a call op, which will also require what I call a call site. A call site basically describes any method that may be called. It's really not that complicated. So here, this is a normal static function. So we'll just seal up call instead of call virtual. Now we have to create a new call site, a boxed version of it. So it needs a class it operates on. So once again, this will be the .NET string type. The name of the method we will be calling is concat, as you can see, because this is what the C# compiler does to concatenate string. I want to closely mimic the inner workings of .NET in order to avoid some issues. Basically, since I know that whatever the C# compiler generates is valid, if I do the same thing, it should be valid too. That's basically my entire philosophy. My entire viewpoint on generating still. I want to stay as close to all the examples as possible, while still, like, I want my code to still be Rust, and I want it to be efficient, but I also want it to be similar to whatever the C# compiler generates, because, well, .NET is optimized for C#. I don't want to deviate too much. This was supposed to be concat, and its signature, once again, it takes in an array which contains array of inputs and a single output, like this function signature constructor. And this particular function takes in 2 strings and returns us 1. There's also a variant of this function which takes in more strings, I believe up to 4, but here we only need to concatenate 2 strings. And I didn't want to make this particular method all that efficient. Like, I know in the future I could make, when I will be working on the fields, I can make some very, very, because right now each string concatenation is quite costly, like relatively costly in .NET, because it involves allocating a new string type. So generally you should avoid having too many concatenating too many strings. What are you complaining? Oh, because I did that instead of extend. That's kind of silly. Extend. Okay, so here the issue is that it's okay. I have to turn it from a static string into an own string here, and it's not just a normal string. I'm using boxed str because it's slightly more efficient to store it, like, because it has only length. It doesn't have a capacity because you can resize the string type in Rust. It's slightly bigger. And using a boxed str, I can save up, like, I can improve performance, and I don't mutate those strings anyway. So it's also a good reminder for me that I shouldn't modify those strings, because I have to do a whole song and dance if I ever want to modify them. So this basically keeps me from modifying things I shouldn't. Another thing I like about Rust, that I can do that. I can kind of stop myself from expected one argument found free. What happened here? Function. Oh no. Oh, because. So let's first of all yeah, I should probably create this call site outside of this op anyway, because then I will be able to reuse it and just clone it instead of creating it from scratch every single time. Expected 4 arguments, found 1. Okay. Expected 4 arguments, found 3. Well, okay, so is static, and then what's your issue? Oh, yeah, single. Oh, so here it wants an option, optional .NET type ref, because all the Rust functions in a compiled assembly belong to the same type. This type is called Rust module, and it basically stores all the code of a compiled, all the Rust code when it gets turned into C. It's all stored in one class. So an optimization that I do is I basically don't store the if I store none as a reference to the class, it will know that okay, it's not an external class, it's this Rust module class which stores all the Rust code. It basically makes the temporary representation on disk on the hard drive slightly smaller, and it also makes serialization and deserialization faster and cloning, and overall it's a nice little performance improvement. Yeah, and it also stops me from making mistakes because, for example, if I wanted to rename this Rust module to something, I don't know, like Rust code, if I decided that I don't like this name anymore, I have to change it in one place instead of changing it everywhere. So that's like another nice thing. Okay, so this function is absolutely static. So it's static true, and okay, so now we have a call site to concat, and this will now load the local variable 0, load this constant string, combine them together, and then we have to set, like we could return right now, but I still prefer to, I don't know, I guess we can just return now. I considered storing it back into the local variable, but there's no reason to do that. We can just return here. Okay, so while fields are not handled yet, we already have a skeleton of our formatter. It's like bare bones without anything, but it's like I wanted to explain some stuff, and I think doing stuff slightly slower to explain it better. Like it's not that big of a trade-off. At least I hope it's not a big trade-off. Okay, so we can now try to create the two. It should be called create ToString. So now we can. Okay, there's some slight differences because I like here it's. I should probably follow slightly better coding conventions, internal coding. What's your? Okay, so our reference. It needs our. Okay, so I could probably even remove the need for a reference since it's cheap to copy. And here I need to do that. Okay. Yeah, so I don't know. I could probably and probably should follow some slightly better conventions when it comes to type names, but I have gone through several revisions when I changed the way I name some stuff because I want my names to be as clear as possible. This has the downside of like I change a lot of stuff, which is not okay. And here it takes on a type cache. So now for each struct we should see an added method. Okay, so we also need to use the set ops function to set the operations that make up a method. Okay, and then we can just return it. and this should now work. And now when I will run a test, such as okay, I should have probably kept an older version to show the difference, but okay, like, oh, so now, oh wow. So we have nbody.il, and if we search in this file, we can see, yeah, so for example, for panic info, it already started emitting the formatter. It created a formatter, and you can see this will, if we just, no, this is a relatively big type. I believe I also have, yeah, this type is much smaller and self-contained. So we can now, because this is, once again, this website was a saving grace because it really simplified a lot of stuff. Okay, so now we can see, okay, it has some issues like this, so I would have to, this website for some reason sometimes just breaks and doesn't want to print out code that's perfectly valid, because, like, once again, this is identical to what the C# compiler emitted. Sometimes it even refuses to decompile C# code. There's a bug there. The website is very nice, but it's sometimes like turning IL back into C# just sometimes fails. I have a solution for that because I have USpy, and we can open this assembly in USpy. Like, USpy is not native to Linux, so that's a bit of an issue. But I don't know. We can then load our nbody, and we can, but like USpy has the benefit of just not breaking, because this website tends to break a lot, and this just doesn't, which is really nice. Like, yeah, here we can see it basically creates this string text and appends at the end this character. Yeah, so basically that's how you create a method. Like, we can also start going through the fields, but okay, so first let's check the kind of the ADT definition. It was ADT dot kind ADT-def.kind. Yeah, so now it will return us, no, it should be ADT kind. Okay, ADT kind, and we should have, we will do nothing for enums or unions right now. Like, getting enum variants is a whole other story, so I wouldn't like to do that now. I would like to just focus on structs, because structs are simple. There is a very simple layout. We can just get all their types and print their names for now. Then I feel I will probably leave formatting the individual variables for the next episode. Or no, I feel there is some stuff there, for example, with regarding to fat pointers. That's kind of difficult, but I believe, yeah, I should be able to have a very basic version. Okay, so for field in ADT def.r fields. So now we can iterate through each and every single field, and enum, not string. I'm a bit stressed if you haven't noticed. Field, not field. Okay. So now we can, loading fields is actually surprisingly easy. All you need to do to load field is call the helper I have as is so now we should have a field and field index. The owner type is basically the reference to the type this field belongs to. Oh, that's okay. No, this should be optional. Yeah. Okay. So what's the issue now? Okay, that's a bit of a problem because type cache generally may be called without a method. It may be called in a context where there is no method, and in such case I don't pass an instance. So I guess I could just skip those types. I can just do if method is none, then I can just okay, can do if let some method. That's a much nicer solution. Oh, because it returns me as 32. I believe this was no. Where is it? Okay, I should probably just look at how my other code handles that when I convert structs to field in all fields. Oh, because I don't create field accessors for those. Okay, so how to turn field def into I forgot that field def humility and oh, I think I know what I did. I'm always confused about the order of so I don't know, for some reason the order of elements returned by enumerate is a bit confusing to me. So now we have received what I call a field descriptor. A field descriptor basically describes the field. It's used by operations such as loading, setting, or getting the address of a field. So now we can do all. Now we can also get the type of the field. If we do field dot type, we can check like if it's a primitive type, then we could easily print it. Like if it's either okay. So let's do for now floating point numbers, because floating point numbers are relatively easy. Everything else we'll just ignore for now, because this is just a very basic skeleton of a more complicated thing. Okay, so then we can add the operations field.x. No, what I'm doing. Okay, seal up, load field. Then we will we have to first load the implicit this this argument. We will do that using the arg, and then after that we'll just call ToString on the type of the field. We should be able to just do call virtual and we will also again need to create a call site. So that's, yeah, because it's kind of weird because floating point numbers are a class and not a class at the same time, kinda. Like they inherit from objects, so you can call ToString on them, but then you have to do a whole song and dance to get that. I believe it's not simple at all. Like we could add the number a here, and you can see that we have to use this class name instead of just using int32 like we use here. So that makes stuff more complicated. So I would have to basically map the primitive types to the .NET definitions. Okay. Sadly, I don't believe I have time for that. So we can, for now, just print the field name without printing its value. I would like to do more, but my time is sadly limited today. So we'll once again, yeah, it's not that. Yeah, I'm still. It's just way too much work to get this, formatting. I believe this could be a whole like additional 30 minutes, and I would like to keep this video under an hour because, well, for half, kind of, I don't know. It would be kind of difficult to do something longer than that. So we will need the name of this field, and once again this field descriptor comes in handy. You can have name, this, and name is equal to field.name. Yeah. Okay, so now format and some capitalization. This should not work. Okay, so now we first will load the local variable name number 0. Then we will load the string, and then we'll just append it. We'll first call to concat. So we should probably move the definition of probably move concat here. Then I can just call concat right here, so it will concatenate, append to end of the string we are currently operating on to its end. It will append this, and then in the future it will also append the value of this particular type, of this particular field. But it's like it's a bit too much for one day. Concat, and then we'll just set the same local variable. And then call into to then into box form. Okay, so now when we run stuff, we should be able to see when we once again look at ilspy. We should see, okay, so this will basically append the string one by one. In the future, like here, we'll also have the values of the field, but yeah, it's a bit late and I'm slightly limited on time, so I feel while I would like to do more, it's a good enough place to stop. Like, I feel I have shown some quite interesting things, and I plan on doing more things like that. So I guess goodbye and maybe see you next time. And subscribe if you are interested in that kind of stuff, because I am going to be doing more of it. Or don't if you are not interested. I know. Goodbye. That's all I want to say.